Awesome, thank you, Ben, and hi to everyone else. Thanks so much for joining us. We're going to be talking about 4 questions to ask your dev team.
So talking to developers, that's a question. Why would you want to do that actually?
Developers are always complaining that our work as a platform team takes too long.
And they don't care about production.
When developers ask for new services, they always get it wrong, ask for the wrong thing and waste our time.
And usually they also think that anyone can log into AWS and do it themselves.
Today, we're going to be talking about how to improve communication and collaboration between development teams and platform teams. Because in our experience, these teams don't talk enough and they don't talk about the right things.
We'll be taking the role of the platform team today because this is what we know best. But that doesn't let any of you developers have the hook. You can start this conversation also.
I'm Hannah Foxwell.
And I'm Jérôme Wiedemann. And we are both Associate Directors for the VMware Pivotal Labs Platform Services in EMEA.
That's right, we do the same job. We're a dream team. Between us, we look after all of VMware and Pivotal's customers in EMEA. Our mission is to create wildly successful platform teams within each of those customers we work with.
So technology is the easy part. It's usually the people problems that are the most difficult part of what we do. And so today we'll share some advice on how to start solving those problems. 4 simple questions to ask your development teams.
We've got a lot of ground to cover, so let's get started with the first question. How are we going to work together? Whilst we want teams to be as autonomous and as independent as possible, we can rarely deliver any value in isolation. We need to work with other people. Good fences make good neighbours, and knowing who does what helps us deliver that value. There are many ways you can organise teams in your company, but this is a pattern that we have found to be successful and that we recommend to a lot of the teams that we work with. So the application team delivers apps and services to the end users. They take on a DevOps model, they build it and they support that service in production. That application team is enabled by a platform team, and that platform team provide a platform service to the application teams. Again, they are building it and they are supporting it. And then underneath all that, we have the infrastructure team who are providing infrastructure as a service to the platform team. They're enabling the platform team. They build it and they support it in production. And I think what's really good about this model is that every team is essentially on the same mission. They just have different users. The application team's mission is to build an amazing product and a valuable service to their users. The platform team's mission is to build an amazing product and a valuable service to their users, but their users are the developers of the application. And then the infrastructure team, again, they're building an amazing product and a valuable service for their users who are the platform team, or they might actually be the application teams or some other teams as well in your organization. In fact, the infrastructure team might be provided by a public cloud provider. So your infrastructure might be provided by Amazon, Google, or Microsoft. The point is that somebody is building an awesome product that enables the other teams to exist. There are some other organizational structures and patterns that we've seen work in the teams that we work with. There are occasions when you need to ensure separation of duties between dev and ops because of regulation and regulated environments. But what you need to do is you need to make sure that you're communicating and collaborating. You don't want to be throwing things over the fence into production. We've also seen it work where there are additional tools teams that are supporting with tooling platforms that anyone else, any application team or any platform team can consume. So for example, CI/CD tooling might be provided by an independent team. Monitoring might be provided by an independent team. But the point is that they're providing it as a service. You've not got an organizational silo, and you're not dependent on those people every day to deliver a production service. And then we have SRE, or site reliability engineering. This is quite often established as a separate team within the organization following the Google model. However, we think that actually everybody can adopt a lot of SRE practices within their teams without creating a separate team. And if you do create an SRE team, try to approach it as an enabling function. Have the SREs enabling the application and the platform teams to build more resilient production systems. But the question was, how do we want to work together, not how are we going to organize ourselves? The developers that you support are never satisfied, and they will always keep asking for more. To believe that you can build a platform once and that it will work for your application teams forever is not going to happen. This never happens. We need to embrace change. We need to embrace change because end users' needs are changing, and that will drive change within the applications. There'll be a need for new applications and new technologies that will replace the old, and everything will need to evolve and iterate rapidly so that you can meet the evolving needs of your users. Your developers' needs will change, and therefore your platform will need to change, and that is to be expected, and we need to embrace that. This is why we believe you need to manage your platform as though it's a product. So for example, we know that the users of the applications, their needs are going to change over time as technology evolves. The product manager within the application team is tasked with understanding those user needs, creating a roadmap and a backlog that the application team can work through. And then the application developers need to be enabled by more platform capabilities. And this is where the product manager in the platform team comes in, because the product manager in the platform team is talking to their users in the same way that the product manager in the app team is. The product manager in the platform team is having conversations with application developers, figuring out what new features to build, building a roadmap for that platform, and prioritizing that into a backlog for the platform engineering team to deliver.
So let me give you an example of something that happened to me some years ago. I used to work for a company some years ago, and this company was working with a waterfall model. This company wanted to build a private cloud for their developers so that their developers could go faster and be more autonomous in requesting VMs to deploy their apps on it. So this was, as I said, some years ago. So Kubernetes, Cloud Foundry was not a thing at this point in time. What happened is this company started by writing specs of what they expected. This took maybe 6 months to 1 year consultation with companies that could help them, etc. After that, they started to build this private cloud. So using all the tools with all the software vendors that answered their RFC. So it took, in the end, almost 2 years from the idea to going live, almost 2 years. And once the platform was in production, they expected to have, after 1 year, around 1,000 VMs running on it. The thing is, well, after 1 year, they only had 25 VMs running on it. The question was then, why did that happen? And it happened because at no point in time during those 2 years, they considered the user's needs, and they never actually tested their assumptions in production with real users. So maybe 2 years ago, when the project started, the requests from the developers were correct, and what they put in place 2 years after was matching those requests, but it was 2 years later, so it's already too late in time. So what we want is to iterate quite fast and to have feedback about what we put into production so that we can improve over time and deliver value faster. So this brings us to the second question, which is what is your path to production and how can we make it easier? So many organizations I've worked with have evolved processes over time that make the path to production really difficult and painful for application teams. And we want to help solve that problem. Josh Long, who is a Spring advocate, says that production is the happiest place on earth. And actually, it's the only place where value gets delivered to users. And it is the only place where it is possible to collect useful data and feedback to continuously improve the service. What you will want is to get as fast as possible from idea to the same idea running in production to deliver that value. A lot of organizations are scared of changes in production because it can break. But what makes a system, it is change. We're not going to be talking about the usual ETL and change management process here. We're going to talk about trusting and giving your teams the freedom to go to production whenever they feel it should be the case by introducing sane practices and proper checkpoints. And we've definitely seen some insane processes in some of the organizations we've been working with over the years. So, why would you want to clear the path to production? Well, it's all about going faster in and delivering amazing value to your users. So the DORAS report, DORAS means DevOps Research and Assessment. This report tells us that there are 4 metrics measuring your delivery performance. The first one is deployment frequency. This is how often you deploy changes to your services and make them available to your users. So if you look at the table, you will see that you're really good if you can do that multiple times a day. And you're in like considered as medium if you can do that between once per week and once per month. The second metric is lead time for change. This is how much time you need to go from code committed to the same code running in production. So again, if we go back to the table, you will see that if you can do that in less than 1 day, then you're really good. If you can do that between 1 week and 1 month, it's quite average. The third metric is time to restore service. This is how much time is required to restore a service when an incident impacting end users occurs. Again, back to the table, if you can do that in less than 1 hour, you're really good. If you can do that in less than 1 day, you're average. The last metric is change failure rate. And this is how much changes lead to service outage. On all those metrics, you will want to tend to be in the elite column. And we helped a lot of customers to go from medium to high or even elite. So you will want to target low value for each aspect to be able to deliver value faster to your customers and to keep them happy. Try to see where you fit in this table and let us know after the talk. So automation helps you build reproducible workflows. It helps you free up time by reducing toil, time that you can then reinvest to create and deliver value to your users. Basically, you want to automate yourself out of the job, otherwise manual work will only increase while your service is scaling up. If your team is split between dev and ops, and again, you should really consider carefully that option, ops should feed back the pain points to the devs so that it can be addressed through proper automation. No one wants to do 100 times the same actions every day. You don't want to have all tests done at the end. You want to fail fast. Test-driven development is another way to build confidence and trust that a change is not going to break something else. TDD is about writing the test before the code and then write the code so that the test becomes green. You might want to introduce tests at every step in your path to production. In the application code, you can do unit tests, integration tests, user tests. In the platform deployment automation tooling, you can also introduce tests, like testing that you can still push an application to the platform, or that every application is still working, etc. And security teams could also provide a comprehensive test suite to ensure your apps and your platforms follow the security guidelines of your company. Remember, what we want is to go faster. So all those tests should be part of the automation tooling in place, obviously. Another tool which helps with change is the feature toggle. So features toggles allow to release features to users separately to code deployments. So you can turn it on or off. That's the way it works. It massively facilitates rollback in case a problem occurs also. So just switch the feature off and you're back on track. It can be also useful if you want to release a feature to a subset of users. And you can build, in this case, confidence before releasing it globally.
So using some of those practices, we've helped unblock the path to production. Now we need to support that service in production. So the third question is, what level of reliability do our users need? We want to make sure that we're clear about what the end user's expectations are and what to do. And what do we do to make sure we understand that? We talk to the people who know the users best, the application delivery team. If your application is unavailable, your users are going to be unhappy. It doesn't matter if you're delivering amazing features at lightning speed. If your service is unavailable, too slow to use, or unreliable, no one will use it. Reliability is a fundamental product feature. If your application is unavailable, your users will be unhappy. That's a given. If your platform is unavailable, then your applications are unavailable and your users are equally unhappy. And then if your infrastructure goes down, for example, then your platform goes down and your applications go down. And guess what? Your users, they're still unhappy. Reliability is everyone's shared goal. Reliability is something that we can't deliver in isolation. Everyone needs to take responsibility for it. And this is why I always say reliability is a team sport. So I'm going to talk about some of the ways that we can measure and talk about reliability, not just in isolation in our teams, but how to work across teams. I'll talk about the concept of a service level indicator, service level objective, and an error budget, which are really intuitive ways of measuring reliability of a single service. And we're going to apply those to a distributed team who are all part of delivering that value to a customer. So to start with, a service level indicator is a metric. It should be unambiguous, easily measured, and it should indicate whether your users' needs are being met. So if you were building an e-commerce website, you might want a service level indicator around, can I add a product to my basket? Can I check out and pay for a product? These are things that relate to user happiness, and it's very easy to understand the impact on a user if the SLI is not being met. If you're building a platform, again, your users are the application developers. So your SLI might be something like, are the apps available on the platform? Can a developer push an app to the platform? Those are your SLIs. A service level objective is your target, and it's a threshold that's described often as a number of nines. For example, 4 nines would be 99.99%. That would mean that you're meeting your SLI 99.99% of the time. The important thing about defining your SLOs appropriately is that your SLO is never 100%. Not even the internet is 100% available. There's always a very small amount of expected and tolerable failure within your system, even if it's very, very small indeed. As a platform team, it's also a really good idea to think about what service level indicators and service level objectives you want to set in pre-production. Now, that might not sound intuitive, but think about where your users are. Your users are working in pre-production primarily. And I can guarantee you that this is a great conversation starter, showing development teams that you care about their ability to work productively and that you've set targets for yourself to providing the systems and the platform that they need to do their job will help build bridges. Finally, I'll talk about the error budget, which is the inverse of your SLO. So you've set your SLO. It might be very high, but it's not 100%. The error budget is the small amount of tolerable failure. It's the amount of service outage that you have accepted based on your SLO. So for example, in pre-production, your SLO might be quite low. You might be able to operate successfully at 2 nines. You might be able to accept 403 minutes of downtime. I like to talk about error budgets in terms of time. That's not the only way you can measure an error budget, but time is a concept that everybody understands and can easily reason about. It also gives you a very clear set of objectives when we talk about time, because if you look at 4 nines, we're looking at an error budget of 4 minutes in a 28-day period. Well, 4 minutes isn't enough for your on-call engineer to get paged, potentially in the middle of the night, wake up, get their laptop out, log on and start remediating a problem. To achieve 4 nines, you need to be looking at very high automation and resiliency in your system. You need to build in a lot of automated failover so that there is very limited human intervention when there's a service disruption. So if your end user of an application expects, say, 3 nines of availability, then we have an error budget of 40 minutes. If the platform team used that whole error budget, then that doesn't leave any error budget left for the application team or the infrastructure team. And that's not fair. They need to make changes too. Again, reliability is a team sport, so we need to agree this together. How are we going to manage this error budget? We want to share responsibility for users' happiness. So I'm going to work through this example based on 3 nines. So if we have an error budget of 40 minutes, that needs to include the entire error budget for the IS team and the platform team as well. So the more dependencies you have, the higher levels of availability you're going to need to provide. The platform team absolutely must provide a higher level of service than the application team. Otherwise, the application team have no hope of meeting their SLO. Remember, the end user really doesn't care which team took down the service, only that the service was down. You need to have a conversation between all the involved groups about SLOs before they become a problem. You need to agree an error budget policy. You need to agree what happens if any one team who's part of that chain that's delivering value to users exceeds the error budget, because that needs to change the behavior of all other teams to support the restoration of service. This is an example, a really simple example of an error budget policy. So for example, if the service is performing at or above the service level objective, you can continue to release changes as normal. But what if the service has exceeded the error budget in a 4-week window? Well, you might want to halt all changes apart from priority 1 and 2 security fixes, for example. You don't want to stop patching your system. You want to remain secure, but you might not want to push a high-risk feature at that moment in time if you've just come out of a period of instability. And again, you might want to set rules around what constitutes an incident. An incident, for example, could be defined as something that consumes more than 20% of your error budget. And that could trigger a number of different actions. For example, a post-incident review might include at least one action to address the cause. The point is that you need to set up an error budget policy before you need it, because you don't want to be debating these things immediately after a production incident.
We've got about 3 minutes left, guys, 3 minutes.
So things will go wrong, and proper incident management is going to help reduce downtime, improve reliability, and make your team happy about it. question is, what are we going to do when things go wrong? As Hannah said, 100% availability is not the right expectation. Pacemakers and anti-blocking systems might be exceptions to this. It's the nature of building complex systems. Failure happens. If your availability is too high, developers will just tend to think that it's the new normal. In this case, you should voluntarily inject failure in your system so that developers keep building resilient applications. If your availability is too high, it also means you do not take enough risks, and you could probably go faster in releasing new features. This obviously comes with proper monitoring in place. So if your system is automated enough, like it is the case with Bosch, for example, that only problems impacting your users should trigger incident response. Alerts shouldn't be sent to everyone for everything, and alerts should only be sent for problems which require immediate actions or because it impacts your end users. You should carefully consider what kind of alerts would trigger a response from a team. There's no need to wake someone if there is a payment processing error, but instead waking him up if there is a significant drop in payment processing rate. Divergence from a baseline is usually a good sign that something is going wrong. A lot of problems can have automatic remediation sets, which circles back to the value of automation we spoke about earlier. Black box and synthetic monitoring from outside of the system is a way to get a view of what is happening from the perspective of your users. On top of that, canary applications tell you quickly if the problem is related to the platform or to the application. You want to replicate the workflow of pushing an app to the platform, for example, and this gives you quickly a view if other dev teams may be experiencing the same issue. Why would you want to do fire drills? So organizing fire drills or game day is a way to build organizational muscle memory. You don't want to figure out how to access the system or where the password is at 3 a.m. in the morning. A way to make this happen is to divide your team into sub-teams for one day, for example. One team is breaking random things on the platform and the other team is working on getting them fixed. This will also tell you if your system is resilient enough by introducing random failures. Some companies even introduce things like chaos monkeys into their system. Blameless incident retrospective is probably the most important of all. It will help you improve over time. What learnings can you take out of an incident? The goal, Blameless incident retrospective is the core to the SRE culture. And it assumes that everyone involved in an incident had good intentions and did the right thing with the information they had at this time. If a culture of finger pointing and shaming individuals or teams for doing the wrong thing prevails, people will not bring issues to the light for fear of punishment, and nothing will ever improve. So you will want to trigger an incident retrospective in some cases. For example, if a user visible downtime or degradation happens beyond a certain threshold, if you have data loss, if resolution time is above also a certain threshold, and obviously if a monitoring failure happens, which usually implies that your end users are telling you that your platform is down. The idea for this is improvement, reducing downtime, and making the overall system more resilient. So in summary, talk to each other and never stop talking to each other.
Be curious and start a dialogue between these teams. Ask, how are we going to work together? What is your path to production and how can I make it easier? What levels of reliability do our users need and how are we going to deliver that? And what are we going to do when things go wrong? Be curious and start a dialogue. We've given you some ideas of how to get started, but what are the problems you feel most urgently today? What's important to you? That will tell you where to begin. And then finally, keep asking this question: are we getting better at this? There are always opportunities to improve and continue to learn from each other. So when you go back to the office today or log in and work from home, Start a conversation. You might be surprised what you learn. Thank you.
Thank you.
Wow, thank you so much, Hannah and Jérôme there, sharing tons and tons of real field knowledge, because I know that you folks are out there with our customers, working in their offices, in their environments, helping them through all this stuff. So acres and acres of experience there. We have a few small questions. I'm going to try and get to the next presenter on time, but we do have time to answer a couple of questions. So let me try this one for starters. How do you foster TDD in the teams that you work with?
I think one way to do it, like what I've seen in the past, is customers are usually not really for putting in place TDD, but the way we usually try to introduce this is when they apply some upgrades, for example, to the platform or do some changes. Sometimes it fails. And we use that as a way to introduce TDD in their practices so that, for example, they have a blueprint application running on the platform, or we set up a blueprint application and we test against this blueprint application that any change made to the platform is not breaking this particular application, for example, or that if a change in the infrastructure doesn't like break the platform either, like a firewall change or load balancer change. We really want to make sure that this continues to work. So TDD is usually introduced after some time when the team already experienced some failures and they want to understand how to avoid them. So then we put in place TDD.
Right, so you use it as a safety net tool, and it's a good point to introduce that is when you have some scars, right?
Exactly.
So perfect. Okay, thank you so much. So